I wrote this linear recurrence function. Can you figure out how to make it run fast enough and get the flag? Download the code here. Sequences.py. Google matrix diagonalization. So if you Google matrix diagonalization, you get to this article from Wolfram, and basically you can take a matrix and convert it to a diagonal matrix, like a pre and a post. And so what we'll get is we can actually just raise this diagonal matrix to the power. So I'll show you the code that we've got. So in their original code, they had this recursive function, and the recursive function looked like basically we were saying return 55692 times m of like m func of I minus 4 plus this negative 9549 times m func of I minus 3 plus 301 times m func of I minus 2 plus 21 times m func of I minus 1. So that's the recursive function that they had, but that thing just takes forever to run. So I first tried to just do memoization, where I created an array of all these numbers. That also took way too long. So I need to compute the 2 times 10 to the 7th, which is like 20 millionth value of this function directly. So by diagonalizing, and I got that from simp.py, so I diagonalize this, I compute the inverse, so I have p times d raised to the power of 20 million times p inverse. The initial values that were given were 1, 2, 3, and 4, and we just want the first value of that, because that's going to be m func of 20 million. So the things that are on the left are this 1, 0, 0, 0 times p. The things that are on the right are p inverse times 1, 2, 3, 4. So I then, because I only want to do division ones because I'm worried about rounding and terrible things, so I compute the GCD of everything in R, and I multiply R by that. We'll divide by that f later to cancel that out. So in the diagonal matrix, I'm going to raise each of those to the I power, which is that 20 million. I'm using MPZ to make that math go fast. Then I'm doing the multiplication of the L and the R. Then I add it together and I divide by F. So that's the answer. So we can run that. We have to wait a little bit while it chunks it its way up to 20 million. And there we go, there's our flag, big numbers.